Section 2.1, Inductive Reasoning and Conjecture. Finding and describing patterns. Geometry, like much of mathematics and science, developed when people began recognizing and describing patterns. In this section, you will learn how to recognize and describe patterns of your own. Sometimes patterns allow you to make accurate predictions. When you make predictions based on patterns that you observe or knowledge that you have, they are known as conjectures. The process of making conjectures is known as inductive reasoning. Example 1, describing a visual pattern. Sketch the next figure in the pattern. Okay, we have one block, and then we have 3 in that shape, and then we have 3 up and 3 across, and we have 4 vertical and 4 horizontal. So the next one, so 1, 2, 3, 4. Next one will be 5 up, 5 across. Like that. Example 2. Look at the patterns below, analyze a pattern, and draw the next figure in the pattern. Got a rectangle, triangle, circle, rectangle, triangle, circle. Next one is going to have to be a rectangle. B. A rectangle. Got a rectangle with a line on the diagonal. Then we've got a rectangle, 2 lines. The next one, if we were just going to repeat this right here, it would be a rectangle with a line going left to right. Describing a number pattern. One of the most useful skills that you can develop in mathematics is the ability to describe and extend a pattern in a sequence of numbers. Look at the number sequences below. Describe the pattern that is used to determine the next number in the sequence. Then make a conjecture about the next number in the sequence. So for this, we have to look and see how these are changing. They're going up. So let's see if we can do it with addition. If we add something to 1, we would have to add 3 to 1 to get 4. And then to get to 16, we would have to add 12. To get 64, we would have to add 48. So there might be a pattern there, but it's not the easiest one we could find. Let's see if we can multiply. We multiply 1 times 4, that gives us 4. 4 times 4 is 16. 16 times 4 is 64. So our pattern, multiply by 4. So if we multiply 64 by times 4, that would give us 256. B. To get from 2 to 4, we would add 2, but then we would add 8, then we would add 36. That doesn't make sense. Let's see if we can multiply. 2 times what gives us 4? We multiply by 2. And then to get 12, we would multiply by 3. And then we would multiply by 4. Then we would multiply by 5. So next we're going to have to multiply by 6. So 2, then 3, then 4. Our next number is going to be 240 times 6, which is 1440. Example 3. Analyze the following number sequences, then list the next 3 numbers and identify the pattern. Okay, these are going down, so let's start with subtraction. To get from 18 to 9, we would subtract 9. And if we subtract 9 again, it would give us 0. Subtract 9 again, it would give us negative 9. So it looks like subtracting 9 is going to be our rule. So negative 9 minus 9 is negative 18. Subtract 9 again, it gives us negative 27. Subtract 9 again, it gives us negative 36. So our pattern for that one is subtract 9. B, let's see. We're going from 6 to 8. So if we multiply, that would be a fraction. So let's just add. 6 plus 2 is 8. And then plus 4 would give us 12 plus 6. So plus 2 plus 4 plus 6 plus 8 would give us 26. And that's right. Plus 10 would give us 36. And 12 would give us 48. So add 2, add 4, add 6, add 8. C. We're going down in this one. We're going from 64 to 32, so that's a drop of 32. And we would subtract 16 to get 16. Subtract 8 to get 8. Okay, so there's a pattern there. Well, let's see if there's a division pattern. 64 to get 32, we would divide by 2. 32 to get 16, we divide by 2. 16 to get 8, divide by 2. So divided by 2 must be the rule. So 8 divided by 2 is 4. 4 divided by 2 is 2. And 2 divided by 2 is 1. So our rule here is divide by 2. Finding counterexamples. A conjecture is an educated guess that you make on information that you are given or patterns that you observe. To prove that a conjecture is true, you must prove that it is true in all cases. To prove that a conjecture is false, you need to find only one example where it is not true. This false example is known as a counterexample. Example. Consider the conjecture all birds can fly. Can you think of a counterexample to this conjecture? So can you find an example where something is a bird but it cannot fly? Think about that for a second. Okay. A penguin. A penguin is a bird, but it cannot fly. So a penguin is a counterexample to all birds can fly. Example 4. Determine whether the following conjectures are true or false. If they are false, provide a counterexample. A. If an animal is a dog, then it barks. Okay. Can you think of an example of an animal that is a dog that does not bark? A basenji does not bark. So A would be false, because we found one example of an animal that's a dog, but it does not bark. Look at B. It says if two numbers are negative, then their product is positive. Is that always true? If two numbers that are negative and you multiply them, do you always get a positive number? Yes, you do. So that one is true. C. For all real numbers, the square of the number is greater than the number itself. So anytime you multiply a real number by itself, do you automatically get a bigger number? Well, if you're multiplying decimals, if you multiply 0.5 times 0.5, that would give you 0.25. And that is smaller than 0.5, so your answer is false. That would also work with fractions. If you multiply 1 half times 1 half, it gives you 1/4. That would also be false. D. All months have 28 days. Is it true? Are they all have 28 days? Of course they do. Now, if this said all months have just 28 days, it would be false. But this one says all months have 28 days, so that is true. Take a moment, pause the recording, and then fill in the blanks. Okay. When numbers in a sequence are increasing, the operation to use is either addition or multiplication. When numbers in a sequence are decreasing, the operation to use is either subtraction or division. And then finally, can you find a counterexample to those two conjectures? Can we find something where the numbers are going up, but we are not using addition or multiplication? Or can we find a counterexample when the numbers are decreasing? It's going to be subtraction or multiplication or division. Well, as we just saw, if you're working with decimals, the sequence would be decreasing or multiplying. So our counterexample would be when you're working with decimals.